Hello, everyone. Welcome to day 2 of the 33rd Annual FIRST Conference. I'm Josh Crandall from the FIRST Events team, and I'll be helping out with host responsibilities on the webinar today. Before we get started, I'd like to remind everyone that speaker Q&A will take place in our conference Work Adventure platform. If you are just joining the stream and are not pre-registered, please send an email to events@first.org. Again, it's events@first.org to get set up on the system. Work Adventure is hosting all of our conference networking activities as well as the conference exhibit hall. And with that, let's go ahead and get started. I'll pass the mic over to Adley, our session moderator.
Thank you, Josh. Welcome, everyone. Welcome back to the 33rd First Annual Conference Virtual Edition. This is day number 2, and I'm sure all of you are excited to be part of this event, just as I am. Now, the next session, this session that we're having now, we have 2 presentations. The first one will be on root cause analysis in Dell's PSIRT. And to do that, we have David Spencer, Senior Manager, PSIRT Engineering, who will be delivering the presentation. So Dave, whenever you're ready, the floor is yours.
All right, thank you very much. My name is David Spencer. I lead the PSIRT engineering function within Dell Technologies, and I want to thank you for taking some time out of your day today to listen in this presentation about how we within Dell's PSIRT group handle root cause analysis. Just a little bit of background about myself. I won't spend much time here. I've been in this role leading the PSIRT engineering team for about 2.5 years, and prior to that, I was doing software development for a variety of product teams within Dell and EMC. Most of those product development roles had some amount of security embedded in them. And then I made the jump over to the product security organization within the last few years. So I don't think I need to explain to people that are attending this conference how important root cause analysis is in a secure development lifecycle. It's built into all the frameworks that we follow, whether it's SSDF or ISO 27001, even FIRST's own PSIRT maturity model, all require the use of root cause analysis to learn from the incidents that happen to our products and applications. But I will just spend a moment on this slide just to refresh for everybody why it's so important. So obviously, when you're developing software in a secure way, you do have various security controls that you're hoping that your development teams are utilizing when they write their software. You have security education programs, which you're hoping they will attend and learn from. And then you're hoping that those security things take hold. And when the product teams do their development and testing, they're doing it in a secure fashion. But no matter what happens, you know there's always going to be vulnerabilities that somehow escape this process. And if you can learn from those vulnerabilities and take those learnings back into your security controls, back into your security education, back into how the teams are doing their development and testing, hopefully that process improves your stance overall. And so every vulnerability that escapes your development environment is a chance to learn something about something that went wrong and prevent that specific thing from happening again. Maybe prevent things like it from happening again to other product teams throughout your company. So before we dig into how we are approaching root cause analysis currently, I think it's important just to give a little bit of background of how the security stakeholders work within Dell Technologies. This model is certainly not unique, and I've vastly simplified it for this slide. But of course, we have a product security organization here in the middle, and that product security organization has a number of teams in it. The 2 that I've shown here are the ones that are of interest to this conversation. We have a team that's responsible for our secure development lifecycle, which we term SDL. And we have a team that's responsible for vulnerability response. Specifically, we'll be talking about PSIRT, product security incident response teams. So these 2 teams handle all the security incidents in a centralized fashion, right? All the security practices and incidents within the product security organization. But within a company like Dell, there are hundreds of different product and application teams scattered throughout many different business units in the company, each of which having people of varying skill when it comes to security and varying expertise and knowledge about security practices. And so we have a program like many of you do, where we have security champions embedded in those teams And the security champions are developers or testers or product managers or all of the above who have some level of security expertise and are considered in their team the subject matter experts on security. And they are the ones who interact most closely with us, whether it's during development when they are looking through the SDL practices that they're supposed to be enforcing on their teams, or whether it's during the vulnerability response cycle when they are helping make sure that the process is handled properly and that the issues are remediated properly. So that's sort of the picture. Just as a background, the conversation that we're going to have assumes that is in place. So when we look at root cause analysis in a company like Dell, the immediate concern you have is around scalability. Root cause analysis was always a part of our secure development lifecycle, whether it was done in a centralized fashion or in a distributed fashion, it was always there. But over the last few years, we decided to take a look at it and try to make a process which was going to be driven through our PSIRT organization to formalize it a little bit. And we'll talk throughout this presentation about why that is and how we did it. But when you try to do that, you immediately run into a little bit of a scalability issue. You have the vulnerabilities that are coming into our organization, discovered by, in many cases, external finders outside the company, whether it's researchers or customers or folks that are signing up for a bug bounty program. You've got hundreds of different products and applications, all of them in varying stages of maturity in their security journey. And you have a PSIRT team, which is lean. And sometimes maybe you might talk to some of the engineers, they might tell you that they're a little oversubscribed, that the work, they were already busy before we decided that we wanted to sort of centralize this root cause analysis procedure. So given that scenario, we have a lot of interesting questions to ask about how are we going to approach the problem of root cause analysis? What sort of quality information do we want to get about this? Certainly one approach to root cause analysis would be to say, let's pick a small number of very interesting security issues and dive deep into them, sit down with the product teams and dig into it. Another one might be to say, let's get a little bit of information about every single issue we have. There's trade-offs on both approaches. You want to be able to come up with a solution that we can automate and fits into our existing automation capabilities so that as the product problem scales, our solution scales. And we sort of have to make decisions about what types of work we're going to prioritize when it comes to root cause analysis. So we had a lot of questions to ask. And in the end, we decided to focus on kind of the primary question about root cause analysis, which is answering what happened. What was it that happened in this situation that led to us needing to have this vulnerability? Oops, sorry. So some of the things that could have happened, there could have been gaps in how the SDL procedures applied across the company. We call that a gap in the SDL coverage. Different organizations are at different levels of maturity, and gaps in how those procedures are applied to those organizations might have led to an issue. There could be a situation where the SDL procedures didn't focus on a particular issue, or that the team didn't focus on a particular SDL procedure. It could be that there was an error, quite common, right, where a team is trying to do the right thing but falls short. There's this interesting scenario here, which is a team might have acknowledged that there was a risk here, didn't think that it was going to actually result in a vulnerability, but it did result in a vulnerability. And then there's this last scenario, which would be a truly novel vulnerability, something new that has happened that we were totally unprepared for, and this is a chance to learn from that. So with that in mind, that was our initial focus. These, we want to be able to take every issue and sort of categorize it into one of these buckets. The question became, how do we approach the problem in a way that lets us answer those questions for the highest number of vulnerabilities possible? And so that sort of drove us to focus more on the quantity side of the equation, as opposed to doing a deep analysis on the quality side of the equation. What that gives us a chance to do is to turn our scalability problem into a solution, into a feature. So instead of being a problem, it now becomes a selling point to say, we have a lot of data coming out of this root cause analysis because we've decided specifically to gather it about so many issues. So with that approach, we really faced some early struggles, and I wanted to document some of them here for you. And every single one of these bullet points could be a hallway conversation or a whole slide on its own, but I would just want to run through them and give you a chance to see a little bit into how this decision to do root cause analysis in this way led to some interesting conversations. So the first one that I want to call out is messaging. You use the word root cause analysis, and people who have engineering backgrounds immediately think of a bunch of engineers huddled in a room with the door closed for a few days until they come back with a specific recommendation of exactly what procedure needs to change so that this never happens again. And while that's certainly appropriate for some types of root cause analysis, we were deliberately not targeting that type of situation here. And so one of the things we did was start modifying the vocabulary when we talked about this. We sort of drew this picture for people of multiple levels of root cause analysis, where at the very top level is this level 0 that gives you enough information to make some changes without needing to do that deep dive that we're talking about. And once we started using that messaging, it started becoming a little more clear what problem we were trying to solve. Another problem that we faced specifically at Dell had to do with our asset categorization. So when we started talking to different stakeholders, it became immediately clear that there was different groups that cared about different types of assets when it came to doing root cause analysis. So our initial focus as engineers was proprietary code. We want to know what, here's a chance where you guys were writing code and something went wrong and we want to help you fix it. But it turns out that a lot of our application teams are doing some level of customization of off-the-shelf applications. And there's just as many opportunities for things to go wrong there. And those teams really want to learn from the vulnerabilities that they face as well. And so figuring out how to make that mixture and how to prioritize those issues is pretty important to us. Another problem we ran into once we started to scale this up was in normalizing the outcomes that come out of it. So the initial impression to sort of get this process off the ground quickly was to sort of do this in a free form way and let the engineers provide as much data as they wanted to. But it became pretty important early on to sort of force people to put their answers into very specific buckets. It was the only way we could deal with the scale that was going to come up. One example of that would be we made a decision to sort of map every vulnerability, as we already did for normal procedures, into a CWE. And then once you have that CWE, we can do some further automation and mapping based on that. So take the CWE and map that to the specific security control that should have, in theory, prevented that common weakness enumeration, that error. So if you say, this particular vulnerability could have been prevented by these 3 different security practices and could have been tested for with this specific type of security testing, that gives us a great place to start in having a deeper conversation with that product team, even if we don't know for sure that that particular vulnerability could have been prevented by, in that specific instance, that specific SDL control. Another challenge that we had to face early on was building a starting point. You take a procedure like this and describe it, and people can start to understand what you're talking about, but it doesn't give you data on day one. This is a process that's going to take some time to build up over time and is interested in sort of historical trends and large scale, what you're seeing on a larger scale. And it's a little harder to sell that to somebody and explain that you're starting this up and that they might see some interesting data in 3 months. So what we had to do was sort of go back in time and sort of do a what if. What if we had been doing this procedure for the last 6 months? What sort of data would we have gathered? So we started collecting that data and took the engineers offline a little bit and said, go pretend that you're doing this root cause analysis, go do it for these last 6 months worth of data so that we have some place to start when we have these conversations. Then once we actually had this rolling, we started running into some different types of problems, right? So formalizing the handoff of the data became immediately important. So now we had all this data and immediately we had stakeholders lining up to ask for it. And we had to figure out all kinds of interesting questions about who's going to consume this data and how. This is where it becomes really important to sort of understand your own organization and how information flows through the organization, who influences whom, to figure out if I give this data to the governance organization, are they going to make sure that it gets to the product teams in the right way? If I give it to the SDL team that we talked about earlier, are they going to share it with the team that handles education on the SDL practices, or do we need to directly share it with that organization? Figuring all that out and coming up with good ways to formalize those handoffs is it's a continuing challenge to make sure that we properly navigate the organization. Good problem to have is everybody wants more. So once we started providing this data, people immediately started asking for more things. So our initial focus was on externally found issues that arise from proprietary code, and immediately people said, well, what about third-party components? What about issues that are found internally? And what about issues that are very interesting and deserve a deeper analysis? How are you going to make sure that that happens? So right away, we had to start balancing expectations for how to scale this operation up while we were still sort of getting it off the ground, formalizing the handoff, all the things that we just talked about. And the last example, which is a little amusing, everybody wants examples of root cause analysis. And I ran into that even while putting this presentation together. So it's easy to sort of describe this process and then sort of explain that this is something that's meant to show results over a large scale of data, but immediately someone says, well, give me an example of an issue that you did a root cause analysis on and what you learned. And sometimes it's hard to do that because the pitch here is really about giving you a large set of data about all the issues that you faced over the last 3 months, not about one specific issue that happened to be interesting. So I apologize, this is not my favorite slide, but it does get the point across about how we sort of decided to add root cause analysis into our PSIRT workflow. So anyone who's involved in PSIRT sort of recognizes this overall workflow I've described at the top here, where you take the issue in, there's some triage and analysis, the engineering team, the product team does some remediation on the issue. You have to release and disclose. And then if there's some post-remediation activities that have to take place. What we wanted to do here with root cause analysis was, instead of adding a whole new procedure into our world, we wanted to sort of take some existing and some new stakeholders and sort of add some new actions into this process all along, so that we could show value just by adding a little bit of incremental cost onto an existing workflow that was already pretty complicated. So during the triage analysis phase, for example, we ask our PSIRT team to gather a little more information and provide a little more information, do some digging. What's the real world impact? What are the weakness details? Those things they were already getting, but now we're specifically asking to make sure that they have enough data to really feed the root cause analysis process. We also ask for a little bit of historical data. Do a little bit of research based on what you know from this product team. Have they run into this type of problem before? That might change how we think about the rest of the root cause analysis. Once the problem has been triaged, once the development team is remediating it, there's a whole bunch of new things that might happen. We start pulling in and working more closely with our counterparts inside the SDL organization. We start asking them questions about their engagements with this team, what's happened in the past, how this team is complying with the SDL controls. They might have this information because they've worked with them as individuals. They might have it because they have automated tools that track these things. However they're doing it, they have some level of information that they're willing to share with us, and we work with them to try and figure that out. We ask the development team earlier on, how are you planning to fix this? Because that gives us a chance to provide feedback earlier. We try to dig a little bit into, based on all the things we've just learned, what we think the technical root cause of the issue is, and sort of confirm that with the dev team. What this gives us a chance to do is sort of provide some just-in-time education. We get a suggested fix, perhaps, we might offer that to the dev team, but we also might be able to provide some just-in-time education to others in there as well. They may be saying, I plan to fix this by adding this filter or doing this deny list, and we turn around and explain why it might be safer to use an allow list, or to not rely on something, or to build in some defense in depth, whatever the example happens to be. Based on all that, we then, into the post-remediation phase, add a little more data gathering. So we pull the actual details of what the fix was. We're not talking about lines of code here, but what did you actually do? And then we make an assessment based on our expert knowledge of what we think this was supposed to do. And that may give us some additional actions. It may be that the team did something that we didn't recommend, but they had their own business reasons for doing it, in which case we may need to open up new vulnerabilities. We may need to track things with the SDL team and explain that there are some changes that this team might need to make in the future because they made a decision that led to some residual risk. So I know I mentioned examples as a problem earlier, but I couldn't let this presentation go by without providing one example. So here's an example of the sort of work that we might do with a specific vulnerability. And this is a real world example. There was a specific storage product that we ran into an issue that was disclosed to us by a researcher or customer. I actually don't remember which one it was. That there was a port on that storage product that didn't require authentication. And turns out it was meant to be on a management LAN, and it was on a front end LAN or something similar to that. And that was reported to us externally, and we had to fix that issue and then disclose it via CVE. So as we talked about, sort of, we have to bucketize that issue. What did we actually do wrong here? And here, as an effort to do that, we looked at the CWE. So we assigned it a common weakness enumeration, 668, exposure of resource to the wrong sphere. And from that, we could look up in our mapping table and say, hey, this team, there was a design objective in our SDL standards that says you're supposed to be applying least privilege. And then there are some verification activities that we recommend you do, some tests that we recommend you run to verify that you have actually applied least privilege. And some of those things might be manual or external security testing. There might be some network scanning that you could do. Threat modeling is almost always an example of something you could do to detect that sort of problem. So we did that, assigned those. That's in an automated fashion. That just happens because once you know the CWE, you can apply those specific boxes. So then we worked with our SDL team and asked them to take a look at the artifacts of their prior engagements with this organization and found that there was a threat model produced for this storage product. But in this particular release, that port somehow didn't make it into the threat model, and it didn't show up during the review of the threat model. And so looks like it was a manual error of some kind. So once we got the fix details provided and reviewed them and said, yep, that sounds like the right fix, it seemed like then at that point we could make our conclusion. So our root cause analysis conclusion, we take that issue and put it in one of those sort of what happened buckets we talked about at the beginning. And in this situation, the team basically did the right things, but there was a mistake made. So there was an activity that was supposed to detect this threat modeling, and there was an error made during the threat modeling exercise that led to this. So this was a port that was missed. And then we made a recommendation back to the dev team and to the SDL organization that in the future with this team, double check and make sure when you're doing a threat model review, make sure that there's a current network scan involved to make sure that nothing was missed. And maybe that recommendation would also apply to other organizations and other times that you're doing threat model reviews. So this is a bit of an eye chart, but basically trying to sort of explain here, now that we have all this data, who's consuming it and who are the different stakeholders that we involve and what data do they need from us and what value are we trying to add to the security posture of Dell by doing this root cause analysis. So whether it's the team that does the secure development lifecycle standards, whether it's the team that manages educating teams on our security practices, we also have the governance organization that interacts directly with the product teams at sort of a senior stakeholder level and executive level to say, hey, these product teams aren't doing X, Y, or Z, and you need to sort of apply that pressure. And of course, our own PSIRT organization is a stakeholder as well. We want data out of this process as well. We want to learn from it and get some value from it. So just going through some of the things that come out of it, right? We know that there's some correlation to the different assessments that teams do with our SDL process. We know that there might be novel vulnerabilities. Those are things the SDL team cares about quite a bit. Those are things that they would want to learn from, and we share that information with them on a regular basis. Our folks who are responsible for our education want to know about gaps in our training. Is there things that we should be teaching people about better or things that we're just not teaching them about at all? Our product teams, our governance teams, and our PSIRT organization, they care a lot about risk, right? So whether these are risks that were acknowledged in the past that materialized and turned into a vulnerability, that's an important piece of information for them. It might be meaningful to go back to an executive who previously signed off on a risk and explain to them, this risk that you acknowledged in the past actually materialized, turned into a vulnerability, was reported to us by a researcher, was blogged about, in the security blog, and gave us a black eye for a couple weeks in the press. And you maybe could have prevented that by making a different decision. Now, maybe that executive made the right decision. Maybe acknowledging that risk was the right chance to get that product out the door, and that's their decision to make. But I think there's some value to demonstrating what happened afterwards and giving them a chance to look back at it. Those same stakeholders obviously also care about new risks that are residual after making a fix. So if part of our root cause analysis determines that this fix that was implemented wasn't complete, we want to make sure that the right people are aware of that. Everybody follows this next piece of data, right? So we want to track what are the most common CWEs that we run into, the most common weaknesses that we might see in the field, and we make sure that we track that information of what we run into. From the SDL and education side also, we want to keep track of which SDL controls and which activities fell short. So in mass, this data gives our SDL team and our education team a lot of places to poke and prod and make fine-tune adjustments to what they're doing with our security education and with our secure development lifecycle standards. It gives them a chance to decide if there's some shifts that they want to make and how we're focusing those activities. Meanwhile, along the same lines, our product teams and our PSIRT organization probably care a lot about similar vulnerabilities that our analysis might find by product line. So if a particular product line, a particular group of related products and applications is running into the same problem repeatedly, that's something interesting that might drive a future conversation with that team. This next item is something, again, everybody cares about, right? So we take all of the data that comes out of this process and pump it into a business intelligence application, and then we can present sort of live sliced and diced data across a variety of axes. So whether it's by date or by business unit, by criticality, by what type of reporter it was, by CWE, whatever it is, we can sort of present that data and do custom dashboards for different stakeholders. And everybody really is excited about the ability to sort of see that data and see it live, being able to go into a business review with a product team and show them, what's happened over the last 6 months with the vulnerabilities that have come in on the different products that they're responsible for. It's a pretty compelling story. And the last one is the one that I'm the most excited about, is the ability to sort of provide just-in-time information based on the outcomes of these analyses. So there's obviously, in any group, the size of Dell, there's sort of a procedure for making sure, how do we update our education? How do we update our secure development lifecycle standards? But there's also a chance to produce these, bursts of information that are highly targeted and have to do with real world vulnerabilities that are coming in. And we always had this capability before, right? If an engineer came to us and said, hey, I noticed this problem came up 3 times in the last year, it would be nice to educate people about it. But here it's more formalized. We can hopefully see these things by finding patterns in the data. And then we can look each quarter and say, maybe it's a good time for us to put together a short webinar about cross-site scripting because we're seeing it grow in these particular business units. Or maybe it's a good chance for us to put together a blog post about code signing and how important it is, or about least privilege, or whatever the problem that we're seeing crop up more frequently happens to be. So that is one of, and the fact that decision is not just based on one PSIRT engineer catching something, but rather by the relationship between our PSIRT organization and our SDL organization and the other stakeholders that we've talked about in this process, I think it adds a lot of value. So where are we and where are we going with this process? As I mentioned, this process is something we've been maturing over the last couple of years. And it's really starting to show some promise, and people are really paying attention and interested in it. So we are maturing this process. As I mentioned, we're getting it incorporated into every aspect of our PSIRT workflow. We're producing these live.
You have a few minutes. You just have 2-3
okay.
minutes. Yep.
Thank you very much. We're putting together these dashboards that I talked about in our business intelligence tools, and we're really starting to evangelize that data and get it out to the different stakeholders who might care about it. And part of that process is accepting feedback on the data and learning from what different people need. Like I mentioned, in even some of our earliest conversations, we figured out that we were targeting some information that wasn't helpful to some business units and that we needed to sort of widen what we were looking for. So that leads to the next step, really sort of working with our stakeholders. We have regular reviews set up to make sure that we're talking with our SDL team, with our education folks, with the governance organization. We're making sure that the data is getting shared during regular business reviews. And then what's next? Well, we do know that we want to do these sort of deep dives that I talked about. We want to identify candidates for really interesting problems and do those deeper dives. So we've got to figure out how to modify the process to enable that and make sure that happens. We want to widen the net and figure out what sort of problems we might want to try and attack that we're not looking at right now. And we want to build up experts within our development teams who are capable of doing this sort of analysis on their own and driving it themselves, so that we're not the only ones responsible for driving the process. So maybe we do this top level process and we help our dev teams sort of do those deeper level analyses and then work out some way to share the information back and forth, because the data really has to be both within the dev team and within the security organization for us to really amplify its value throughout the whole company. So last slide really quickly, what is the data telling us so far? There's not a lot here that should be surprising. This sort of information that we're seeing is stuff that the teams are already pretty aware of. We know that the critical issues that we're facing tend to come from application teams that don't have as formal engagements with our SDL procedures as some others do. We know that for teams that are already pretty mature and following all the right practices, they probably are at a point where they need to optimize that and do more security testing and more fuzz testing. We know that researchers are pretty good at finding issues that relate to authentication and authorization. Again, no big surprise there. The sorts of environments that researchers are attacking are slightly different than the ones that developers are testing in. And we have found a very small number of issues that have some newly residual risk. So something new that was discovered during root cause analysis that we need to document going forward. Very small number, but they are there. So it's good to see. But I think the real message is, ask us again in a year. We'll be maturing this process, and hopefully I'll have a chance to speak again about this another time. Thank you very much. And I will be in the Work Adventure platform answering questions after the session.
Sounds good. Thank you very much, Dave, for sharing with us on how the PSIRT at Dell Technologies does root cause analysis. I'm sure our audience truly appreciates the insights and have learned a thing or two tonight. Or today. And for the audience who is interested to engage with David, please head to Work Adventure. He'll be there to answer questions or have a discussion with all of you. So thank you once again. Let's give him a virtual round of applause. Thank you, David.
Thank you very much.
All right, everybody, the program will continue with the next presentation. We have now Cleberson Silva and Nicole Rickman, and they are both will be speaking on the CAIS RNP experience in Brazilian General Data Protection Law, LGPD compliance. So without further ado, I would like to invite both of them to share their presentation and start sharing with us. We're seeing your notes.
Hello, everyone.
Hello, yeah, we can hear you.
Okay, and can you see my presentation here?
I can see your presentation, but we can also see your notes. Maybe you can unshare a different screen. Or...
Ah, okay. Let me try.
Yeah.
Okay, can you hear my presentation now?
Yep.
Can you show? Yeah.
Is that your slides?
Yes.
Okay.
It's okay.
I think we're seeing something else. I'm not sure exactly, but it's not. I don't think it's your slides that we're seeing.
Cleberson, tá aparecendo a parte dos slides aí, tipo, apresentação de slides, não tá aparecendo os slides.
Em modo apresentação, né?
Não sei.
Yep.
Agora.
Perfect. Go ahead.
Agora eu tô vendo só Pronto.
Eu inverto aqui. Mas agora tá...
Agora deu certo.
Mas sumiu para mim aqui. Sumiu os comentários aqui.
Okay, we can see the slides.
Você quer tentar colocar aí, Nicole?
Peraí, que eu não tenho eles aqui. He can see the slides, but he cannot see the comments, so he cannot present all the slides without his comments. Se você deixar assim, você não consegue ler o que está escrito, é isso?
É, eu não consigo acompanhar.
Aí você quer que eu coloque a apresentação para não ir lendo, é isso?
É, pode ser.
Vai começando, que como eu falo começo, aí dá. Eu tenho que baixar aqui. A gente está demorando muito já. Por isso que tem que testar antes. Você tá com duas telas aí?
Pô, acho que é isso que tá dando confusão aqui.
Você não consegue compartilhar uma tela só e deixar outra tela em paralelo aí?
É, eu tô fazendo,
Just a second, everyone. We're just adjusting here some screens. We'll start in Agora não está aparecendo nada.
Agora, continua a mesma coisa, né, Nicole?
Não está aparecendo nada, está preta a tela. Por que você não joga os slides e coloca o... Agora está aparecendo os slides sem os comentários.
Tá certo agora?
Sim.
Ah, ok.
Vai lá.
So, let's start. Okay, sorry for the... hello, everyone. Good morning. First, it's a pleasure to be here in my first time on first conference. I hope you are doing well and staying safe. My name is Cleverson. I'm a information security analyst on CAIS, CSIRT from RNP. And here today with me is my colleague Nicole. Hi, Nicole.
Hello, everyone. I'm a cybersecurity analyst at CAIS RNP Brazil. And I'm sorry for the delay, but we hope you enjoy our presentation.
Well, together we are going to talk about Brazilian GDPR law, or LGPD as pronounced in Brazil, and the experience of CAIS and RNP. Okay?
So, RNP, or RNP, is the Brazilian National Research and Education Network, and is the organization that plans, designs, deploys, and operates the academic backbone that provides access to federal and public universities and federal research institutes, some private universities, totalizing almost 2,500 units as academic campus in the entire country. Our backbone reaches all the 27 states of Brazilian Federation, some with more capacity than others, but always in constant expansion. As part of our backbone already has traffic at 100 Gbps.
I'll tell you about CAIS. CAIS is the Incident Response Team of Brazil Research and Education Network. We are on the road for 25 years and we manage the information security incidents and also offer technical support, security awareness to users, and security vulnerability handling. Then I'll invite you to visit our page and learn more about CAIS, okay?
The LGPD is inspired by the European regulation GDPR, as already we told you. The LGPD was approved in August 2018. It applies to any business or organization that processes personal data in Brazil. In other words, it regulates the activities of personal data treatment in Brazil. So if the company has any customers or clients in Brazil, or offers services or have operations involving data, it should begin preparing for LGPD. LGPD defines authorized legal basis, principle of personal data processing activities, rights of personal data subjects, and guarantee of risk handling and security controls in personal data processing.
What is the punishment applied by the law? Companies that violate the LGPD will be subjected to the applications of warnings, fines, suspensions, and partial or total bans to perform their activities. Fines can reach up to 2% of the organization's revenue, with a limit of 50 million per violation.
The academic network, RNP or RNP, handles personal data in internal processes and provides advanced IT services to Brazilian academic community that handles some personal data. And the academic institutions can handle students, teachers, researchers, and employees' personal data in its administrative processes, and can collect and handle personal data of research activities or public health context.
We address the challenge of support LGPD compliance actions through four main fronts: RNP internal adequacy, RNP consulting as a service. This front has specialists on the topic to support research and education organizations in the work of adequacy to LGPD. Privacy training, and the last one, development of LGPD implementation method for customers' use. This front helps to share knowledge and provide inputs, workshops, study groups, and training about privacy and data protection to prepare the institutions to adequate themselves. Beginning the data map. The data mapping is very important to view and identify how the personal data flows inside the RNP works, the company works. Once you have this understanding, you can make a strategic plan to answer some questions like, how much effort do you need to adequate your environment? How many resources do you need to LGPD adequacy? How to begin the LGPD adequacy? Well, here in this illustration shows we did some steps to perform the data mapping. Here we have the first step, identify the focal points inside the company and answer some questions about the workflow. Second step, sending the data mapping spreadsheet to them. Third step, schedule an interview to validate the understanding and consolidate the data map. And the last one, perform the risk analysis. So as you can see in this illustration here of data map, can show you the methodology used. According to the label in the right side here, we have the blue circles representing the software, yellow circles representing the hardware, light orange representing the area or departments. So you can also see the small green circles here, the D1, D2, D3, representing the type of data. As D1 represents employees, D2 for partners, D3 for external users. In this example, we have three internal systems inside the data center: system A, system B, system B. The corporate email stored in the public cloud, corporate email here, is stored in the public cloud, and also an external agent. And here we have the office law. We also can see the arrows pointing the data flows directions. The area point using the system B, the area using the corporate email and receiving the email for another areas or external agents. So after the data mapping consolidated, the risk analysis was performed considering the probability to possible data leak of personal data. This possible data leak of personal data includes all circles, all points here in the data mapping. Number of IT systems not approved used to store data. Data leak points in an external environment. Here in this example, we have the office law. And data leak points outside the vulnerability management process and the percentage of LGPD adequacy plan run. The impact consists in personal sensitive data, where sensitive data value 10 and no sensitive data value 1. Quantity of personal data, number of different types of personal data. In this example, we have 3: employee, partners, and external agents. And as result, the probability versus impact gave us the understanding to put in order and classify the most critical areas and the most critical systems to prioritize its adequacy. Until now, all data mapping was done inside RNP along 6 months, and we got some numbers inside RNP. 76 spreadsheets fulfilled, 36 interviewed areas, processing of 5 types of personal data identified, processing of 3 types of sensitive personal data identified, 86 IT systems mapped, 58 IT systems that process personal data identified, and as the result, we got 10 most critical areas and 10 most critical systems to prioritize to LGPD adequacy. Also, I'll tell you some benefits obtained with data mapping. Good understanding of how data moves in and out inside the company. View and documentation of data lifecycle from collection, use, storing, and the understanding of relationships of our company's processes, systems, and areas.
Beside all that, we have the training, the Network Academic School ESR, as a unit from RNP, provides to academic community training about privacy and data protection for managers, data protection officers or DPOs, and other public or private stakeholders. More than 150 professionals were trained until now.
Our goal: support Brazilian academic community to be compliant with LGPD, and more, help create a privacy culture in their entire activities. Share practical experience acquired in the adequacy process, and work together with the other organizations to improve the privacy governance. That's all. Thank you very much. Everybody have any questions?
Thank you, Cleberson and Nicole, for sharing.
Thank you all.
For sharing some insights on how you guys are dealing with the laws there. For Q&A, if people would like to ask questions, all the Q&A is done in Work Adventure, our social engagement platform. So if you can all head there, I guess the participants will be there to ask questions. Once again, we'd like to thank you for your time and spending the time to prepare and give the presentation to the first audience tonight. Thank you once again.
Thank you.
Thank you very much.
All right. Over to you, Josh.
All right, we're going to take about a 20-minute break, and then we have our panel session that will start in breakout room 1, and that's going to be the only one that's going to happen over the next hour. We'll see you there. Thank you.
Thank you, everyone.